Next, we have to understand different types of electrodes. Last topic that we completed, people, was Daniel cell, and we did functions of salt bridge. Okay, now people, we've already done the first type of electrode, which is this. यहाँ पे क्या था people? Which electrode is this? Zinc, which was dipped in which solution? Zinc sulfate solution. ठीक है? Or what we have here is a metal, and that metal is dipped in a solution which contains its own ions. Zinc dipped in ZnSO4 solution, so the ions were Zn2 plus. Yes or no? Now this rod here, or this metal which is dipped in metal solution, can behave like an anode, but it can also behave like a, वो prediction अब तब बता सकते when it is connected to another half cell. So I repeat, this can behave like a cathode, or it can also behave like, for example, let's say यहाँ पे if I want to understand its cathode behavior. So when it is behaving like a cathode, what will happen here, people? The metal, sorry, the ions जो है, these ions are deposited, they accept electrons and they are deposited on the rod, because cathode पे क्या होता है? Reduction. Reduction means gaining electrons. So the ions जो present थे solution के अंदर, what they do is they will accept, gain electron and get deposited in the form of solid metal on the rod. Getting that? Any questions still here? Similarly, if the same electrode has to behave like anode, तब क्या होता था? Oxidation. So metal comes in the solution in the form of its ions. So this is anode, and what happens anode pe, people? Oxidation. What exactly was oxidation? The metal from the rod coming into the solution in the form of its ions, and rod पे क्या छोड़ दिया था? Leaving behind electrons on the rod. Such an electrode is called as metal ion electrode. What do we call it as, people? So as the name suggests, the metal is dipped in its metal ion. अब वो कैथोड भी बन सकता है, वो एनोड भी बन सकता है. How will you represent them? What do I mean by represent them? You started with Mn plus, which got deposited on the rod. M solid, M aqueous. ये एक सिंगल लाइन क्या रिप्रेजेंट करता है, पीपल? चेंज इन फेस. So that is the representation of cathode. How will you represent here anode में? M S. The metal came into the solution in the form of its ions. M N plus aqueous. Any questions here? Yes or no? Now, this is the rod. Metal is getting deposited on the rod. Solution में क्या बन गया था, people? Excess of, and the rod gets positive charge. I repeat, because ions from the solution are getting deposited on the rod. So solution में क्या बचेगा? Negative charge. तो हम बोलेंगे इलेक्ट्रोड पे क्या चार्ज है? Positive charge. Do you see a potential is developed? So when the rod undergoes, or when the electrode undergoes reduction, it develops a potential, और उस potential को हम क्या बोलेंगे people? Reduction potential. ये जब हम electrode potential पढ़ेंगे तब इसको और डिटेल में फिर से पढ़ेंगे, but I just want to give you an पहले से एक overview. Similarly यहाँ पे क्या होता है? What happens here? The metal is coming into the solution in the form of its ions. Solution क्या बनने लगता है? Positive. Rod पे electrons हैं तो that will be negative. Again positive and negative charge difference, मतलब there is क्या developed? A potential is developed. This potential will be called as oxidation potential. Where did we study this? SRP, standard reduction potential, standard oxidation potential. Excellent. DNF, उसमें हमने एक सीरीज पढ़ा था Mn+/ the SRP was positive only for one element, copper. अब वहाँ पे इतना इन डिटेल नहीं गए थे, बट यहाँ पे जाएंगे. बट डिड यू अंडरस्टैंड द फर्स्ट इलेक्ट्रोड? क्या बोलते हैं फर्स्ट इलेक्ट्रोड को पीपल? मेटल इन मेटल आयन इलेक्ट्रोड. नाउ सेकंड, in the second type of electrode what we have is same, हमारे पास एक solution है, but this time the solution is made up of H plus ions with concentration 1 molar, or you can say it is HCl solution, concentration 1 molar. ठीक है? What we have here is an inert electrode. Can someone give me an example of an inert electrode? Excellent. Platinum, graphite, nickel, so on and so forth. Now what we do is, on this inert electrode, पूरा diagram बनाया नहीं है, but we bubble hydrogen gas, and hydrogen gas is adsorbed on the inert electrode. What do you mean by adsorbed? Only on the surface. So I repeat, hydrogen gas which is at 1 atmospheric pressure is adsorbed on the surface of the rod or on the surface of the inert. So it behaves as if it's a gas electrode. You cannot really make an electrode of hydrogen. हाइड्रोजन का इलेक्ट्रोड पॉसिबल नहीं है, तो हम क्या करते हैं, हम एक इनर्ट मेटल लेते हैं और उसके सरफेस को हाइड्रोजन एटम से कवर कर देते हैं. So it starts behaving like a hydrogen electrode. This is called as gas electrode. Yeah, we can call it as gas ion electrode. Did you people get that? Now again, this gas ion electrode can behave as per requirements like a cathode, but it can also behave like, when it is behaving like a cathode, it will undergo what? Reduction, which means it will accept electrons, which means the H plus ions from the solution, वो H plus ions क्या करेंगे, electron accept करते हैं and gets converted into H. This H collides with one more H and becomes H, इसलिए short form में 2 H2. Yes, did you people get that? This can also behave like anode. When it behaves like an anode, क्या होने वाला है? Oxidation. इसी का उल्टा H2 gas will come into the solution. So 2H plus plus 2E minus. Did you people get that? This electrode is also called as standard hydrogen electrode. SHE or SHE. Standard hydrogen electrode. SHE is an electrode. Pun intended. Anyways, coming back. ठीक है. SHE standard hydrogen electrode. SHE is a reference electrode. अब इसका मतलब क्या, थोड़ा ना रेफरेंस इलेक्ट्रोड आगे इन डिटेल पढ़ेंगे, but reference electrode is used to find the standard reduction potentials या standard oxidation potential of other elements. आपने जो एक्टिविटी सीरीज पढ़ी थी उसमें पढ़ते थे कि हाइड्रोजन इज समवेयर इन द मिडल, ऊपर वाले एलिमेंट्स एंड नीचे वाले एलिमेंट्स. वो कहाँ से मिला एक्टिविटी सीरीज? Because hydrogen electrode was used as a reference electrode. We'll study more about this in reference electrode lecture and in electrochemical series. But some more points about SHE. The potential of SHE is 0 volts. ठीक है, चलो. I also want इसका representation, cell representation. So what's happening here? Cathode के side पे H plus is becoming what? H2 gas. Whenever there's a change in phase, this is aqueous, yes or no? But there was also something present, a platinum electrode. Did you get that? Yes or no? Why again? One more. Because of course platinum is in what state? Solid. Again change in phase. Getting that? Another way to represent this is H plus aqueous. थोड़ा और डिटेल में. What is the molarity of H plus ions in the solution? 1 molar. So you also write the concentration. Then H2 gas. What was H2 gas का pressure? 1 atm. And instead of putting a dash, inert electrode को आप comma the inert electrode ऐसे भी लिख सकते हो. That is fine. Now give me, how will you represent the anode? So उसी को I will write उल्टा, PT comma H2 gas. H2 gas is at 1 atm and single slash, and this is at. Any questions in standard hydrogen electrode? Now there's a problem SHE में. It's very difficult to maintain. When you're bubbling hydrogen gas at 1 atm, even a slight change in the temperature of the solution, we all know that molarity temperature पे depend करता है. तो थोड़ा सा भी temperature change हुआ, molarity change जाता है, and the functioning of SHE changes. So potential change हो जाता है. Did you get that? So along with SHE as a reference electrode, हम एक और reference electrode पढ़ेंगे जिसका नाम है Calomel electrode. ठीक है, but that will be जब हम when we will have a lecture on electrodes. Okay, now the next electrode that we have is called as sparingly soluble salt electrode. थोड़ा सा tricky to understand, ध्यान से देखिए. Now people, let's say I have a sparingly soluble salt. Where did we do sparingly soluble salts? Excellent. In equilibrium solubility product. Now I have a sparingly soluble salt AgCl. So solution में कौन कौन से ions है? Ag plus and if this behaves like a cathode तो क्या होगा? Ag plus will deposit on the electrode. तो electrode किसका बन जाएगा फिर? Ag का. Yes or no? So easy. मार्केट में जाओ, AgCl बोरो करो, घर पे आओ, सिल्वर रॉड्स बनाओ, ओवरनाइट रिच, या गोल्ड सॉल्ट्स लेके आ जाओ, गोल्ड सॉल्ट्स लेके आओ एंड स्टार्ट डिपॉजिटिंग गोल्ड ऑन द रॉड. इज इट दैट इजी? ऑफ कोर्स ऐसा होता तो सब करते हैं. नाउ पे अटेंशन. द प्रॉब्लम इज द सॉल्ट इज sparingly soluble. What does that mean, sparingly soluble? It will not produce any meaningful number of Ag plus ions. So in your solution there are hardly, I should say there are none, पकड़ लो, because हमने KSP values देखे हैं. So there are hardly any Ag plus. Now what do we do in this case is थोड़ा सा rod को tweak करते हैं. So what we have here is we have a silver rod, but a part of it is also coated in our sparingly soluble salt. Which was the sparingly soluble salt? AgCl. And the solution will have a common anion. So what is the anion here? Cl minus. So you can see that यहाँ पे we have a solution of AgCl. So which ions are present in the solution? Cl minus. Did you understand the setup? I repeat. Which electrode do I have? I have Ag electrode, but the electrode is also coated with Ag electrode, coated with gel and your sparingly soluble salt AgCl. I repeat, my AgCl is the sparingly soluble salt, and I need a common anion which I get from KCl solution. Any questions still here? The basic setup. Now when this behaves like a cathode, क्या होता है? Try to understand this. Cathode means what process will take place over here? Reduction. The reduction में what happens is your AgCl or your sparingly soluble salt accepts electron, and Ag, which was present in the sparingly soluble salt, gets deposited on the rod, and Cl minus comes into the solution when this is behaving like a cathode or when reduction is taking place. And when this is behaving like an anode, anode पे क्या होगा people? Oxidation. तो पूरा process को उल्टा कर दो. That is Ag plus Cl minus becomes AgCl plus E minus. Also, what will be the representation? So, we start with which is the common anion? Cl minus. Sparingly soluble salt AgCl, and which is my electrode? Ag. That's the cell representation for cathode. The cell representation for anode will be exactly ulta, Ag. Then we have AgCl, and then we have Cl minus. Now, why is this electrode very important? Because when we do numericals, we connect the sparingly soluble salt electrode and KSP related problems आते हैं along with electrochemistry. So तो वो mix करते हैं the KSP part from equilibrium and the electrode वाला part or cell potential वाला part from electrochemistry और combined numericals होते हैं. So when we do numericals, तभी we will discuss this. Did you people understand what is sparingly soluble salt electrodes? ठीक है. And the last electrode that we have is called as redox electrode. Now redox electrode is for those ions which show multiple oxidation states. That is, let's say I have an inert electrode. Let's say my inert electrode is platinum, and I have Fe solution. जहाँ पे I have Fe2 plus, I also have Fe, because Fe can show 2 plus as well as 3 plus, which means that Fe 3 plus can accept electrons and get converted into Fe2 plus. This is its behavior as cathode, and its behavior as anode will be Fe2 plus aqueous getting converted into Fe3 plus and releasing an electron. How will I represent this? What is happening? Cathode पे Fe3 plus, उसका state क्या था? Getting converted into Fe2 plus, which is also aqueous. And you also have an inert electrode. You can either write it like this or Fe3 plus, Fe2 plus, and the inert electrode. How will you show representation for anode? The same thing but opposite. So PT single slash Fe2 plus comma Fe3 plus, or PT comma Fe2 plus comma Fe3 plus. If we know the molarity, we can also write the molarity below the ions. So these are 4 important electrodes: metal ion, gas electrode, gas ion electrode, sparingly soluble salt electrode, and the 4th one is redox electrode. Next part of the chapter we will study about electrode potential, and then we study how to calculate the potential of a cell, और हम numericals करेंगे based on that. ठीक है? I will see you people next class. Thank you.